In today's lesson, we're going to be talking about fractions as percents. So we're still doing percent, but we're going to kind of see how fractions play a part in percents. Okay, let's take a look at our example. We've got some vehicles here, cars and trucks, and we need to write two ratios to represent the picture. Well, since we're working with percent, and I remember that the definition of a percent is a part to whole ratio, I'm going to make my two ratios part to whole ratios. Okay, so for my cars, I could do cars to the whole. I see 3 cars and 5 whole vehicles. And I could do trucks to whole, make part to my whole, and I see 2 trucks to 5 whole vehicles. So those are my two ratios that would represent this. All right, let's take a look at the next part. This says, Sam says 50% of the vehicles are cars. Give 3 different reasons or models that prove or disprove Sam's statement. Models can include tape diagrams, 10 by 10 grids, double number lines, etc. All right, I don't want to draw a 10 by 10 grid, and I don't have one available at the moment, so I'm going to skip that part. Let's start with a tape diagram, shall we? Okay, we know that in whole, there are 5 vehicles, okay? So I'm going to start with a tape diagram. I'm going to make it kind of large so you can see it. Make a tape diagram of 5 whole vehicles. Okay, so this is the whole. I'm going to split it into 5. 1, 2, 3, 4, 5. All right, if I take, this is 100%, right? We're finding percent here, and he thinks it's 50%. He thinks 50% are cars. We're going to prove or disprove him. Okay, well, with 5, you probably already know the answer, but we're going to prove it or disprove him. We've got to have some examples here. If this is 100%, then we need to figure out what each of these marks is. Just like we were filling in the boxes, I'm going to shade them in here in a minute, so I want to kind of leave them open. So each one, there's 5 boxes. 100 divided by 5 is 20. So this is 0, this is 20%. 40, we're just going to count this. 20s, 60, and 80%. All right, now ignoring the percents, we're going to go back to our numbers. And I know that 3 of them are cars. So I'm going to shade in 3 boxes. These are cars. It's kind of a combined tape diagram here. These are cars. I'm just going to label that up on the top there. And there are 2 trucks. So these 2 are trucks. And together, they make up 100%. So we put those 2 together, and we have 100%. All right, so cars, and trucks. Okay, from this, I can see that 60%, that's where it stops. 60% are cars. So I'm thinking he's not right. So here I found that 60% are cars. Okay, now I need to give some more examples. It says 3. Okay, so I need a couple more ways to show that he's not correct. That's where I'm going because I see that he's not. So I'm going to find out 2 more ways. Let's do a, how about a table, a ratio table. Okay, so 3 to 5 is cars because he said 50% were cars. We're going to see if it works. Okay, we want to get a percent. Percent means per 100. So we want to get this whole. This was the whole. We want to get the whole out of 100. So we're going to make this 100. To get from 5 to 100, we're going to multiply it by 20. So to find this value here, we're going to do the same thing. we're going to multiply by 20. So 3 times 20 is going to give us 60. Again, we find that 60% are cars. Sam, your answer's not looking too strong here. Okay, I have another way. Let's let's kind of use a fraction, shall we? Okay, so he says it's 50%. Well, I'll show you what 50% looks like, Sam. All right, 50% he says are cars. If that was true, let's find out how many would be cars. 50% again means per 100. So that's the same thing as 50 out of 100. Because it means per 100. 50 per 100. 50 to 100. 50 out of 100. Okay. Now if I simplify this fraction, simplify it, don't put simplest form. I know this is like $1. This is like 50 cents. Well, I know there are two 50 cents in each dollar, so I'm going to divide by 50. So this is the same as, if I divide this by 50, I get 1. Divide this by 50, I get 2. So 50% is half. Okay, there are 5 cars. I have a separate problem over here now that I have this half. There are 5 cars. Half of those cars, or there are 5 vehicles, I'm sorry. Half of those vehicles are cars, he says. Okay, well let's find 1/2. We're going to multiply times a half. We're going to cut it in half. All right, to multiply fractions, we remember we put it over 1. 5 times 1 is 5. 1 times 2 is 2. 5 halves. Let me change that to a mixed number so kind of see a little bit easier how that works. So I'm going to do 5 divided by 2. It's going to give me 2. And I'm going to just keep it in fractions because I can kind of visualize halves. And this is going to be 1 out of 2. So if Sam, you think that 50% of the vehicles are cars, that means 2.5 need to be cars. Well, more than 2.5 are cars. Therefore, your answer is not correct. That's 3 ways that we can show that his answer is disproven. It is not correct. We have a tape diagram. We have a ratio table. And we have fractions, percents as fractions. All right, let's look at another example. This example says a survey was taken that asked participants whether or not they were happy with their job. That's important, to be happy with their job. An overall score was given. 300 of the participants were unhappy, while 700 of the participants were happy with their job. Okay, let's mark the important information that we're going to need to know. Okay, so 300 were unhappy, 700 were happy. Okay, oops, I'm sorry. Made that a little too high for you. Give a part to whole fraction for comparing happy participants to the whole. Okay, let's do that real quick before we forget. Okay, so I'm looking here. They kind of give me a little section to do this in. So here's my fraction. I need the part to whole for happy. So let's see, these were unhappy. We have 700 happy. So 700 is going to be my part per whole. So I need to know how many total there were. So how many is my whole? Let's see. 700 and 300 makes 1,000. So we have 1,000 total participants. Okay. Then write a part to whole fraction of the unhappy participants. Okay. So my unhappy were 300. So 300, my whole is still 1,000. So now I have my fractions that I wrote. So part to whole, kind of like a ratio. part to whole, part to whole. Okay. Then, oh, I already did that one. What percent were happy with their job? What percent were unhappy with their job? I have a couple ways to figure this out. All right, I need to kind of adjust here. Give myself a little cushion to write on. Okay. Now, to get this to a percent means per 100. So per 100. I need to get this to 100. So if I take 1,000 and I divide it by 10, I'm going to get to 100. I'm going to do the same thing up here. And I get 70. So my percent is per 100 is 70% or happy. Ooh, that's good. That's great. Okay, I'm going to do the same thing over here. Again, we want to get per 100. So we're going to divide by 10. Per 100 means out of 100. Whatever we do to the bottom, we're going to do to the top. 300 divided by 10 is 30. So my percent that is unhappy with their job is 30%. Okay? Then it says create a model to justify your answer. All right, we haven't done a double number line in a while. Let's try that. That sounds like fun. Okay, I'm going to just do it on the bottom here. All right, a double number line. So we need a number line first of all. Gonna figure this out here. Put some space. Okay, let's start with 1 on the top. I'm gonna make it long so I can see it. And let's make this one our percent, shall we? Okay, I'm going to make my little hash marks long because they're going to go down to another number line that's going to happen down here. So this is going to be 0%. And let's make this 100% because that's the whole thing. Okay, these two numbers are multiples of 10. So I bet if we counted by 10, we would include them both. So let's do that. I'm going to try to split in half. We'll make that 50, 60, 70, 80, 90. Oh boy, I didn't do very straight lines there, did I? So that happens when you freehand it. Okay. This was 50, so this is 40, 30, 20, 10. This is not my prettiest. Okay. So I'm going to number those 10%, 20%, 30%, and so on. All right, on the bottom, I have to start with 0 again. My whole, better draw my line here. Oh, that's much prettier. Okay, my whole participants, this is percent. I'm going to label these, and these are participants. So don't forget which is which. How about that? Okay, my whole participants, excuse me, was 1,000. So this has to be 1,000. 100% of the people is 1,000 people. They are the same. Okay, so this is 1,000 divided into 10 spots. Well, when I divided it by 10, I counted by 100s. Okay, so let's do 100. 200, 300, and so on. Squish those in there, right, small. Okay, so we are supposed to prove our answer, justify our answer. Okay, can do that, no big deal. All right, I know that 700 is 70%. I just proved that. There you go. 300 is 30%. Answer is justified. All right, double number lines. We're going to need a lot more work with those, I am predicting. we will definitely continue using them. They're a good practice and a good strategy for finding those equivalent ratios. If you have any questions, please put them in your ISN so we can discuss them in class.